This A?
Yeah.
Okay.
Project to the point.
Why? Why do we need to project to here?
Because there is an angle
Angle.
of the small a to the map.
Small a to the map. At an angle. Which angle?
Small a to dark a to big A and
So small a to big A.
Yeah. And the small a to the map.
Small a to the map.
Between this line
Here, this one?
在上面那个就是在那个平面的上面。
Okay, Kunyo. Any idea? If I'm going to project these to the A point, what's missing? What's the information missing? Elevation, which is ZA, right? The ZA over here. So, if I want to find out where the small a, the XA and small XA and YA is, I need to have XA, YA, and ZA with a known, of course, with a known EOP. Okay? So, but right now, what I have is the also image, which contains the XA and YA and 0. The elevation is 0. So, I need to know the elevation for this A point. So, where can I get the elevation? It indicates that we need additional data. We need additional data. So, we need to have, for example, dn. We need to have the dn. And the dn as the object space coordinates, x and y, right? So, but however, on the dn, it already record the elevation. Right? It already recorded the elevation. So usually in the process, actually, we will resample the dn. We will resample the dn to the same pixel size with the also image that we want to achieve. Usually, that's how we perform it. Of course, we can perform the interpolation on the fly, but however, the process of that will be like slower. You can say the performance is slower. So usually, we will perform the interpolation. We will perform the resampling first, so that it has the same coordinate with the also image. So, which means that here, when I'm pointing at these 2 and 2 location, and then this corresponding pixel over here store the elevation for this x and y. So, if I call this the first step, which indicates the first step is this step, right? Which indicates that this is the first step. Starting from the also image, the black image, so you have the x and y coordinates known, but however you don't know the elevation. So because we already prepared the dm and resample it to have the same coordinate system with the also image, so that I can go to the corresponding pixel on the dm to get the elevation ZA. After that, I already have the XA, YA, and ZA. With the known EOP, let me just annotate that here. With with the known EOP over here, then we can reproject the A, XA, and YA, and ZA back to the image and to obtain the small xa and YA. So let's assume that this is the reprojection process, and I can get a certain location here. I can get a certain location over there. So if I, and so which means that it is the second step. It is the second step. And the third step is to find out what's the corresponding information on the image, and then you are going to filling back the information to the author image. Just filling that information back to the image. Okay. I'll go over it again very quickly. So we can view the bottom-up solution in these two ways. One is from the, you can say your software, how the software works is like in this view, and the other way is from your geometrical point of view. So what we want to achieve with the auto replication is that eventually we want to perform the like orthographic projection, and we want to obtain a map, and then so which means that all the information is like directly go down to the data. So assuming that I first open the empty author image, and that empty author image, it has the object space coordinates because it's a map, right? So the map has the object space coordinates. That makes sense. So right now for every empty pixel over here, we know the x and y because it's orthographic projection, so there is no elevation. So everything is goes down directly. So when I'm pointing at a certain pixel, and that has the x and y with an elevation 0, and we know that this pixel should store the information of the A point over here, But however, the information for this A point actually is stored on the image at this small A point. So which means that we need to go to the corresponding small A point on the image to get the information so that we know what to fill in. So how to go back to the image? As you can see, for these A points, we need XA, YA, and ZA to reproject it to back projection or to back project it to the small A points over here. So which means that we need, instead, in addition to the author image coordinates, the XA and YA, we still also need the ZA information. And where can we get the ZA information? We can get it from additional data, which is DM. And so with that, we can go from XA and YA and to get the ZA. And after that, we can reproject it to the A point over here. That's the second step. And with that XA and YA, the small XA and YA, we can perform the interpolation and then to get the supposed square value for this certain location. And then we can fill in back to that empty pixel. So that's how you perform the bottom-up solution for the auto replication. Okay, from two different views. Okay, any question for this? Any question for the bottom-up solution? Alright, if no question, then the next solution for the auto replication is called top-down. So as you can see, the y equal bottom up is because it starts from the bottom. It start from the bottom and go up and up to the image, and then fill in the information back to your picture. So it's from the bottom to the up. So top-down means that can I go from the top to the bottom? For example, can I go from the small A point? I have the image already, so can I point at any pixel on the image, and then I project it to the author image? Can I do that? can I do that? Alright, so this is the question for you guys. Think about this. How to perform the top-down procedure? How to perform the top-down procedure? Top-down. It has it needs to perform a procedure usually called ray tracing. Ray tracing. In Chinese, it's called 光线追踪法. Ray is like the light ray, and tracing is 追踪. So you are tracing where that light ray goes. So how exactly can how exactly can you do it? So you can simplify, or you can simplify the question to this. If I want to go from the top to the bottom, so which means that for each of the pixel, for example, let's take some certain A pixel, for example, and this A pixel here. Let's change the action from here. Let's change it to, for example, B. We have the big B pixel, pixel B. We have the pixel B over here. And if I eventually want to know, for example, if I eventually want to know, here is the information, where can I fill in this information to? You should be, for example, as you can see, here is a light from the God's view. We know that here is the DN, so it intersects here. And that's the B point with the XB. YB and ZB. So we know that the information stored over here represent this B point, and if I want to perform the orthographic projection, then it needs to directly go down. To a pixel over here. So this has the XB and YB and 0. So what I want to do is to go from the top, from the B, to find out where the B point is, the XB, YB, and ZB. And after I find it out, it will be very, very easy because I can just remove the ZB and then find out where is the XB and YB on your image. And I just fill in that information over there. Okay? So the procedure is like that. But the question is, if I right now only have EOP and the B coordinates, the XB xb and yb. If I only have this and this, how can I find out where the B point is, the xb, yb, and z? How can I use this and this to find out this? Right now, the unknown is the object space coordinates. And as you know, that in the photogrammetry application, in order to find out the object space coordinates, we need stereo pairs, right? We need stereo pairs to perform space intersection. Right now, we only have one image. We only have one image, yes. How can I go from one image to find out where the B point is? Assuming these are the data you have. Assuming these are the data you have, which means that you have the DN. To be very plain and simple and clear. So you have the DN. If you have the DN, then you can find out the B point, where the B point is. Okay? So the procedure is called ray tracing. Alright, please think about this. I will be back very soon.
Yeah, that's cold.